Welcome to Ask and Learn.
A man drinks 1 liter of cold water at 3 degrees Celsius in an effort to cool down. We need to calculate the drop in the average body temperature of the person under the influence of this cold water. We assume that the thermal properties of the body and water are constant, and the effect of metabolic heat generation and heat loss from the body during the time period are negligible. The density of water is very nearly 1 kg per liter, and the specific heat of water at room temperature from our tables is 4.18 kilojoule per kg degree Celsius. The average specific heat of the human body, we call it CB, is given to be 3.6 kilojoule per kg degree Celsius. So the first thing we need to do in this problem is find the mass of the water, MW. And the mass of water is equal to its density times its volume, rho times V. Now its density is 1 kg per liter, and he drinks a liter of water. And so the mass of water is simply 1 kg. Now we'll take the man and the water as our system and disregard any heat and mass transfer and chemical reactions. So these assumptions are acceptable for short time periods, such as the time it takes to drink water. We can then write the energy balancing relation, E in minus E out is equal to the change in the man's energy, delta E. And so, since there's no work or heat transfer, we have the left-hand side of this equation is 0, and this is equal to the change in internal energy of the man, delta U. So this is equal to the change in internal energy of the body, delta U for the body, plus the change in internal energy of the water. So we can write this equation by writing expressions for the change in internal energy with respect to the temperatures. So that's the mass of the body times its specific heat multiplied by its change in temperature, T2 minus T1. This is for the body, plus the same expression for the water, its mass times its specific heat times its change in temperature, T2 minus T1, and that must equal to 0. So we've just written expressions for delta U body and delta U water. Now we can substitute our values into this problem, and we can find the final temperature of this person. So substituting our values, we get 68 kg, the mass of the man, times the body specific heat, 3.6. So we'll suppress the units here, times his final temperature minus his initial temperature, which is 39 degrees Celsius, plus the mass of water, which is 1 kg, times its specific heat, 4.18 kilojoule per kg degree Celsius, times its change in temperature, which is its final temperature, TF. So we're just calling T2 TF now, minus its initial temperature of 3 degrees Celsius. And this is equal to 0. Remember, the mass, the man water system is 1, so they both have the same final temperature, TF. So we get the final temperature of the man after he has drunk the water to be 38.4 degrees Celsius. So we see indeed his temperature has come down. And so his change in temperature, delta T, is equal to his initial temperature, 39 degrees Celsius, minus his final temperature, 38.4 degrees Celsius, and hence his body temperature has changed by 0.6 degrees Celsius.